Hi everyone, good morning. Yeah, I have shared the Kahoot link. I think yesterday we missed the Kahoot, so today we'll be having two topics. So you guys can join now. Yeah, okay, guys, all the best. Yes, Brahmya. Sir, we have one more Kahoot.
Yeah, sure. You can process.
Yeah, thank you, sir. Yeah, guys, this is for next day. You can join now. Others who didn't join the previous Kahoot, make sure you're joining this. Yeah, okay, guys, all the best. Yeah, well done, guys. Sir, it's over. We can start our session now.
Sure, Asma. Yeah, hi, good
Thank
morning,
you.
everyone. So, yeah, guys. So, if you have any questions from the previous classes, please let me know. Otherwise, I'll jump on to the next part, that is the rest of the load balancers.
Yeah, we can go with the next one.
Okay. Just a second, please. Actually, I need to enable the MFA. Hmm. Guys, just let me know once my screen is visible to you. So, is it visible?
Vivek. Yes, it is because.
Okay. So, guys, yesterday we were talking about the type of load balancers. We have talked about some of the practical scenarios related to load balancers and where do we require the load balancer. So, on the basis of that, in that series, we need to jump onto the rest of the load balancers that we have. So, first of all, let me just start my existing instance. So yeah, let me jump on to the load balancers. So I hope that you are now pretty much aware that what is load balancer, what is the use case of load balancer, and how can we configure an internet facing load balancer. If you have any doubt regarding this, please let me know, because now we are going to have some deep dive onto the load balancers. Okay, I think there are no doubts. Okay. So let me jump on to the load balancer section. So once I click on to the create load balancer, okay. So the next type of load balancer is the network load balancer. Guys, always remember that whenever you require any kind of a just a second, uh, network load balancers. So whenever you require any kind of a application, okay, that is more inclined towards the networking, means they require the high uh, input output speed, they require the higher consumption of the bandwidth. So in that scenarios, we required network load balancers, or in a simple language we can say that whenever we are hosting any application, okay, which is designed to handle extremely high volumes of traffic while maintaining ultra low latencies. There we require the network load balancers. Okay, the best example where in the industry where such kind of a load balancers are being used, the very first one is the entertainment industry. So when I say entertainment industry, whatever the platforms, whatever the OTT platforms, whatever the surfing platforms, or you can say the video surfing platform like YouTube, or any kind of a live coverage. Okay, so all those type of applications required a very high volume of traffic. At the same time, they also make sure that there should not be any kind of a latency while broadcasting the information or while broadcasting the videos. So in those scenarios, guys, we require the network load balancer. Okay, how it is different from application load balancer? So the very first reason is basically application load balancer works on seventh layer of OSI model. Okay, and the network load balancer basically works on the fourth layer of the OSI model. So fourth layer is the networking layer, where fourth layer is called the networking layer. This kind of a layer is responsible for handling networking kind of a things. Okay, so on the other hand, such kind of a load balancer can be used where we need to have TCP, UDP, and TLS traffic we need to handle based on IP addresses instead of the application level content. So when I say application IP based addresses, so you can see that, guys, whenever we are hosting any kind of a application, let's say OTT or any kind of a application, there we require the very high networking. We require very high networking. We have a very high networking requirement there. There, the main concept of the IP address comes into the picture, where each and every user, they are accessing the application continuously through a specific IP. It requires the IP binding concept also. It requires the caching concept also. It requires the cookie concept also. So in that scenario, whenever the application is or on the other hand, let's say if I talk about the Paytm, if I talk about the any other platform apart from the OTT platforms, I'm not saying that all the OTT platforms are completely on a network load balancer. No, the binging, whatever the videos you are doing, all of them are actually behind a network load balancer. The application is designed, because I have worked uh, on such kind of a platform. So how the things are actually there? So they basically segregate their actual infrastructure into two ways. This is your complete infrastructure. Okay, and this is your application load balancer, and on the other hand, this is their network load balancer. So this will be their application load balancer, and this will be their network load balancer, and both of the load balancers are behind a common URL. So when I say common URL, it should be like, let's say, netflix.com. Okay, now what will happen? Let's say here, what application load balancer is going to do here, because as I told you, application load balancer is one of the cheapest load balancer that you can use. So this application load balancer here, whatever the applications you have, let's say the payment, okay, the subscription, and I would say payment, subscription, login, logout, etc. So all of such kind of a servers which handles these kind of a request are completely behind the application load balancer. Okay, whereas on the other hand, if I say the what network load balancer is going to do there, network load balancer is basically, it is having the videos. Okay, uh, live broadcasting. So all those servers will be behind the network load balancer, and those are completely binded with a single a common URL, that is netflix.com. And according to the URL that a user is hitting, let's say if he is hitting the payment page, if he is hitting the subscription page, then the respective requests are basically landed to these load balancer, and these load balancer basically route the traffic to the respective instances. Whereas the same thing happens here. Let's say if I'll go on to Netflix and I'll try to uh, start a movie. So the request will first of all come to this network load balancer, and then whatever the server which is, or whatever the target which is handling such kind of a request, the request will be routed to it. So in this way this network load balancer basically works, guys. Now if you have any kind of a doubt till this point, please let me know.
Vikas, can you one more time elaborate the difference between network load balancer and application load balancer?
Yeah, I am
Why only OTT or video or platforms require only network
I'm not
load
saying that you cannot use application load balancer. That yes, you can do, but as per, because we required a better output. So there, because as I told you that network load balancer is actually designed to handle the networking kind of a request. Okay, so the where you require the very high, I would say the what we call it as, you require the very high, you need to handle a very high volume of traffic there. You require, and you also need to make sure that there should be a low latency there. Okay, although you can use the application load balancer there also, but application load balancer is having its limitation because it is designed to handle the application level of things. When I say application level of things, where we don't require the low latency, where we are not too much focused on the TCP UDP concept. So in these scenarios we can use the application load balancer. Or in a very simple language, you can say that whenever your application, you, let's say you are working in an organization which requires the very high networking or very high bandwidth. Okay, and you also need to make sure that there should be low latency there, then you should go. Because if I would say, if you are trying to render a page of paytm.com, or let's say any platform which is not having the OTT platform or broadcasting platform, if there is a lag of 1 or 2 seconds, that you can handle, but the same thing won't come up with the networking load balancer kind of a thing. Because let's say if a video is keep on lagging for 1 or 2 seconds every minute, so you can imagine the time it is going to take to, I would say, to render the complete data to the user. So that is why, because we have the TCP IP model, we have the OSI model as per our networking topology. So we, that is why we should use the networking load balancer kind of a things there. Okay.
How I'm assuming is like network load balancer is working in the same way how in our household we have ACs and stabilizer. That stabilizer is continuously providing the electricity to the AC because AC requires continuous electricity. On the same way, we have in our house there is one main stabilizer is there which provide the electricity, but there can be cut in that electricity flow. But in AC stabilizer, only that electricity flow is very continuous. It does not break in between. So the same way NLB is working, it does not break the bandwidth or the data flow, and it provides the continuous network or continuous data transfer. Am I
um,
right?
you can, I mean, everybody is having their own way of understanding the things, but yes, the main concept is that whenever your application is more inclined towards high bandwidth and low latency, you should go for network load balancers. Okay, now the other thing is, the other difference between or other advantages of using the network load balancer. So NLB basically handles millions of requests per second without any latency. The example you can say, uh, right now if you see any kind of a live broadcasting, let's say the best example I can give, the IPL season, you all of us might have seen that with there we are getting a count 6.2 cr users are watching, 7.2 cr users are watching. So how the things are basically handled behind, there is a, into the front I would say, there is a network load balancer which is handling all those requested. Network load balancer make sure that your request should not be dropped. Okay, because you also need to make sure that there should not be any kind of a latency. On the other hand, you also need to make sure that the net, whatever the request is coming to your load balancer should not be dropped. So that is why whenever you have a very high uh, user base, always go for network load balancer. The third one is fixed IP concept. This is the core of networking load balancer. So guys, there are some applications, okay, that they generally communicate on specific IPs. For an example, you have seen that when we have created the application load balancer, we have not assigned a static IP to the load balancer. Load balancer is picking its own IP, but there are, in some of the scenarios I have seen that applications require, apart from the DNS, they required a static IP also. And whenever you required static IP with the load balancer, okay, always go with network load balancer, because network load balancer provides the static IP with this with the load balancer. Application load balancer doesn't provide this feature. Okay, another thing is uh, yeah, let's say if you need to preserve the client original IP. Let's say I am the user and I'm hitting a website, and basically application load balancer do not preserve the client's original IP to render the data, but the same thing happens with NLB. So this is the other difference between it. Okay, yeah. So these are the differences. So guys, I would request you, all of you, to please create a application load balancer right now, so that I can, when I start creating the network load balancer, you can easily cope up for the things that what is the difference between the application load balancer and a network load balancer. Please create. I'm just coming in 2 minutes. Okay. I think I need to restart my router. Yeah. Please do that. I'll come in 2 minutes. Yeah, hi guys. Sorry, there was some issue at my end. So, anyone of you tried to create an application load balancer? Guys, hello. Am I audible?
Yes, Vikas.
Okay. Uh, okay, no issues. On the other hand, if I talk about some other comparisons also, okay. So basically, this NLB in the backend, it handles the requests which are TCP based, UDP based, and the TLS based. Okay, whereas application load balancer handles the requests which are HTTP and HTTPS based. This is the first major difference. On the other hand, if I talk about that, whenever you required any kind of a application, okay, which have high performance network traffic, go for the network load balancer. Whenever there is an application where you required routing based on microservices. So based on microservices means, let's say slash Paytm slash recharge. In that scenario, go with application load balancer. Then into the network load balancer, the other difference is it provides fixed static IP for the load balancer. Application load balancer, basically it provides dynamic DNS, okay, not any static IP. The dynamic DNS, we can say, remember yesterday we have created a uh, application load balancer where we were hitting the website using the you can say the DNS name. So that is the dynamic DNS. Okay. Next is, let's say guys, if you need to have a content based routing. Content based routing means, let's say if you want to do, let's say if any URL comes to slash uh, recharge, then it should redirect to slash recharge, slash payment should be redirected to slash payment. So such kind of a scenario are only possible into the application load balancer. These are not uh, applicable for the network load balancers. Okay. Next is, let's say, the other difference is if you want to preserve the source IP. So when I say preserve the source IP means preserves the source IP. So let's say if I am the user and I am hitting the URL, okay, and the URL is having the network load balancer, then what it actually do, it preserves the IP from where the request came from. That base, or in a very simple language you can say, it basically binds the preserve IP with the load balancer, so there should not be any kind of a latency. Okay. Whereas in terms of the application load balancer does not preserves any IP. It basically uses the X forwarded means basically it forwarded your request or IPs to uh, give you the, you can say, to give you the results. So yeah, these are some of the major differences that you can easily got to know between the network load balancer and the application load balancers. Now if you have any kind of a doubt, please let me know. Another example where we can use the network load balancer is the mailing servers like Outlook, Gmail, Reddit. So there we require the uh, it's Reddit, or I forgot the actual name. Yeah. So such kind of mailing servers are also using the network load balancers. Guys, if you have any questions till this point, please let me know. Okay, if no question, then let me try to create a network load balancer for you. Okay, so there we can say that here you can see the requests are HTTP, HTTPS based. Here TCP and UDP based requests are there. Simply create the load balancer. Give the name of the load balancer. Let's say test NLB. What kind of a load balancer you want to create? Is it the internet facing or internal facing? So guys, now I hope that you are aware that what is the internal facing load balancer and what is internet facing load balancer. Still, if you have any doubt on this, please let me know. Okay, so there I'm creating the internet facing. IPv4 will be there. Network mapping, I am basically creating my load balancer in all the three subnets I have. IPv4 address. So here you can see that we have IPv4 address. We are having an option assigned by AWS. On the other hand, we are also getting an option use an elastic IP address. Okay, so because it's my free account, it's not my subscription account, so that is why I'm not getting this option. But once I'm subscribed with AWS, I can easily get this elastic IP also. Okay, and also I need to make sure that before using this, the elastic IP should be created also for me. So let's check that whether we are getting this option or not. And or meanwhile, I'll also create a similar application. I'll also create a try to show you by creating a net application load balancer also, so that you can have a better picture of the load balancers. Create load balancers. Okay, I'll come to this part. There, let's say test. So yes, ALB one. So yes, it will be an internet facing IPv4. So when I say this one, and here you can see that, guys. Once I selected this subnet, okay, I have selected the subnet on network load balancer. So here I am getting the elastic IP concept. But into the application load balancer, I am not getting the any IP concept. So it means that network load balancer basically provided you a static IP concept. Into the application load balancer, we are only getting the availability zones, because we don't want to bound our application with any kind of a IP addresses. But into the network load balancer, as I told you that it is whenever you require a heavy, or you need to handle a heavy traffic, you required a network load balancer where the static IP will be there. So you can see it is giving us an option of static IP, because I don't have any kind of a static IP in my subnets. So that is why I'm not getting this option. Also, I think I need to be a paid member for this. I am not sure on this, but yes, we can see that we are getting the assigned IPs here. Now it's asking for the security group. The same thing here also. After this, it will ask for the security group. Now let's come to the part of listener and routing. Here you can see into the listener and routing, we are getting two things: HTTP and HTTPS. But into the this listener, we are only getting TCP, TLS, UDP, and TCP UDP, which means that network load balancer don't entertain the requests which are on HTTP and HTTPS, because they are more focused onto the networking topology, and there we basically communicate with the protocols like TCP, UDP, TLS protocols. So if you need to select both kind of things, you can use TCP, UDP. For now, I'm using TCP. Port can be anything. I can select a target also. So let me just create a target group for this. Instances are there. Uh, TG underscore NLB something this. You can see here I'm getting TCP, UDP, and all those. Why? Because I have the HTTP and HTTPS also, but because the network load balancer always requires the where it is. Yeah, network load balancer requires the TCP and UDP protocol. That is why I'm not getting any target group, because the earlier target group that we have created was on HTTP. IPv4 I have selected. This I have selected. Now TCP is there. Okay, and next PG hyphen NLB. Okay, next, although this HTTP and HTTPS can be there because this is the health check URL. This is not related to handling the request. Okay, so let me just make it as HTTP also. I can make it as okay slash. If I'll make it TCP, it doesn't going to check for any path. Okay, now, but for now I'll choose it as TCP. If required, I can change it later on. This one. So this is my instance I have. So include as pending, and this is, you can see, has been included. So now create the target group. The target group is created. Let's keep on. Okay, now let me assign this target group to our network load balancer. Sorry, this is our network load balancer.
Okay, sure.
Assigned
I
it.
have a doubt. Like, can we like map the application load balancer also for the for as an target group for the network load balancer?
Yes, we
How
can do
does
that.
that work?
Yes, we can do. I'll let me just revalidate also. But as per my understanding, yes, we can. I'll go this one. Internet facing, internal facing, everything is there. Oh, sorry, I need to create the target group. TG, target group, create target group. Instance IP address, yes, we can map an application load balancer with another load balancer. Okay.
How does that work? Like network load, if we are configuring uh, application load balancer with the network load balancer, how does
So
that
for
work?
that, let's say if you are configuring an application load balancer with network load balancer, so consider a scenario where you need to bound a application load balancer with network load balancer. Network load balancer will have their own IPs. Select the IP address, give the target group name, and go for it. Because you have already created your application network load balancer, you can map that IP address here. But if you want to map a network load balancer with application load balancer, simply click on target, give the application load balancer name, give the target group name, and give the respective things that you are creating. Let's say whatever the details you want to map it, and then you can work accordingly. Here, for mapping network application load balancer with NLB, create a target group and select application load balancer in the creation step. Okay, for mapping NLB with ALB, create a target group and select the IP address of the NLB in the creation step. So in this way, you can map both the load balancers. I hope I'm able to answer your query.
Yes, yes, we can. Thank you.
Why I'm not doing that? Because then we required multiple load balancer and application should be routed like this. Okay, so here I come to the Yeah, target. I think we were creating the target group. Where is the target group creation step? Leave. Yeah, so basic configuration. This is network load balancer. Target NLB we have selected. Okay, and then all the details are there. Create the load balancer. Load balancer is created. It's getting provisioned. Let's wait. So you can see here. Okay, if I refresh this, if I go to network mapping, so it's provisioning. Let's wait for a minute to for it to get provisioned.
Because this window creation of load balancer comes as I mean that AWS search for this creation of load balancer.
Then it is getting provisioned.
Because am I audible?
Yeah, you are audible.
Yeah, I just want to know like if does AWS charge creation of these load balancers or it comes in that fee for the
Sorry, your
vendor?
voice is a bit choppy. I'm
No,
getting a distance
no.
from your end.
So I just want to know like if creation AWS charge for creation of these load balancers
Yes,
or it
it will
comes.
charge. Yeah, it
Yeah.
charges.
But okay. So how can we manage it by creation? How we create it?
So for the testing purpose, you can create it and delete it. In that
Okay.
scenario, you can once your testing is done, then you can easily uh, pop the respective things. Okay. So you can see that this load balancer is created. Okay. If you go to this application load balancer, go to the details. This is your application load balancer. You are getting the uh, all the things internet facing and all these things because we have selected the IP to be provided by AWS only. Okay, because we have selected a specific IP to be provided by AWS only. That is why we are not getting the exact IP details here. But let's say if we select to uh, what I can say, if we select the this Elastic IP, okay, then we can easily get the IP addresses. So even let's say if we go to the if I select the load balancer description, so if I select this IPv4 address type is IPv4 and so there if I click on the network mapping, so you can see that IP is being provided from this CIDR block. Okay, this one. and on the basis of this we can easily, let's say if we need to, because in our scenario we are not creating any static IP, but if we are providing the static IP, we will get the IPv4 address into the networking details. Okay. And another thing here is, let's say, mm, I will, where is the, this is the DNS name. Okay. If I'll come here, clear NS lookup, if I'll check this, so you can see what load balancer. Okay, this is my load balancer. Whenever I'm doing NS lookup, it is giving me a static IP here. Okay, but on the other hand, we have the application load balancer. Okay, if you check the application load balancer, yeah, so if you copy your application load balancer and if you try to do NS lookup, okay, you can see the IPs keep on changing. You can see this is one IP, this is another IP. Sometimes the IP can be different because we have only selected two ranges. Okay, so that is why it is giving us the multiple IPs. But when you check, when you do the NS lookup for the NLB, you can see the IP you are getting always is a static IP. You can create this IP as a static one also. Let's say you don't want to use the IP to be provided from AWS and you just want to use an IP address that is gonna be, I mean, you have created that IP address, so you can simply create an elastic IP and assign that IP during the load balancer creation, and you can use that as a elastic IP for the load balancer. Now you can easily see the differences every time. Whenever I'm hitting the URL, I'm getting the same IP, whereas this does not comes with the ALB case. ALB basically will give the IP depending on the availability in its pool. You can see now it's 3.7, 190.39, something like this, but earlier it was giving us this IP. So you can see that it will only give the IPs to us when any specific IP is available into the application load balancer pool. Now, if you have any doubt till this point, guys, please let me know. Hello, hello, guys, am I audible?
Yes, Vikas.
Now, what you can do, because into the, if I talk about in terms of the application load balancer, you can only map the DNS name because you are not worried about the underlying IP addresses. But into the network load balancer, you can map your DNS name, your IP addresses as well. So means it provides you an extra way of whitelisting your infrastructure. So that is the beauty of using network load balancer. Even if I again give it here, you can see I'm still getting the same IP. So in this way, guys, you can use the network load balancer. So on the other hand, let's say, yeah, one more thing I need to do to communicate with my application. Can any, okay. So what I'll do here is I'll simply click on it. So you can see the page is getting rendered hello world from the IP address. You cannot do this thing with the help of the load balancer, application load balancer. Now, guys, please let me know if you have any type of questions between application load balancer, network load balancer, how the requests are being handled, etc. Whatever the questions you have, you can ask. Okay, if no questions, then I'll jump to the next load balancer. Okay, so what I'll do here is I'll simply go to load balancer. So there you are getting, when you click on the create load balancer, I'll talk about this gateway load balancer after some time, but before that, there is a thing which is called classic load balancer. Okay, now what is this classic load balancer and how we can use it? What is the use case of this and why it got obsoleted? We will talk all those things in a very detailed manner. Okay. Guys, believe me, without load balancer, you cannot imagine to create any application. That is why I am giving some time on this thing. Okay. Now you can see that classic load balancer. So this is the very first load balancer which was provided by AWS, or you can say that classic load balancer. It is the first generation load balancer. So when I say first generation load balancer means that when AWS was in their development phase, they thought to have a load balancer and they created this CLB. Okay, and basically it is designed to basically handle layer 7 and layer 4 operation. It is designed to handle both layer 7 and layer 4 operations. So when I say layer 7 and layer 4 means it can handle HTTP, HTTPS request. Okay, it can handle TCP request also. So that was the use case of using this load balancer. Also, it provides the option of session stickiness, means it basically, session stickiness means, let's say if you are a user and whenever, okay, I'll give you an example. You can see whenever you are hitting this URL of the load balancer, the IP keeps on changing. Why this is keep on changing? Because we have not given a session stickiness. Session stickiness means it will keep this IP for some amount of time so that you can request multiple times on the onto the same IP address. If you see right now the IPs are getting changed, it means there is no stickiness, okay, or there is no bindation of the IP for a temporary purpose. Or in a very simple language, I can say it keeps the session of a user. Let's say if I have given a, I have I have just click on my URL, and after clicking on the URL, for this for some time it basically stores my original IP, it stores my load balancer IP, it stores my request, it stores my whatever the mechanism I'm using to access the URL, all these things for a specific interval of time, so that there are no failure when for fraction of seconds. So that was the concept of stickiness session. But there are then definitely there will be the questions around uh, that, okay, if this kind of a load balancer is having so much advantages, then why it got obsoleted? So reason for its deprecation will be, the very first reason, or the one of the reason, when we are completely in a transition phase of the technology, it does not support static IP concept. This is the first drawback, because as I told you that it designed to handle both layer 7 and layer 4 operations, mean it should handle the HTTP request, HTTPS request, TCP request. But when we are talking about TCP request, we require the static IP also, which was not the part of the classic load balancer. That is why this classic load balancer got obsoleted. Okay. On the other hand, it is being deprecated because it was not designed to handle complex architectures. Complex architectures. Okay. The third thing is it does not support advanced monitoring, logging, and tracing of the request. Means, let's say if I want to, if my requests are keep on dropping, and I want to monitor the things, that why it is going on, why my requests are getting dropped. I was not having a proper traces to figure out that why the requests are getting dropped. So that is why it is also one of the reasons that it got deprecated. Another is that it is not designed to handle the complex architecture of containers or microservices. Means, let's say if I am creating a Kubernetes, I'm creating a Docker. So this load balancer was of no use, because it was originally because it was the very first load balancer. At that time, we don't have the concepts like load balancers. Sorry, we don't have the concepts like containers. Okay. Other thing is, it does not support the host and path based routing like application load balancer. Okay. It does not support web socket. So these are the six limitations which make this specific load balancer as the deprecated load balancer. Now if you have any doubt till this point, please let me know.
In what use cases we will be using this classic programs?
Classic load balancer was initially for the use cases that, okay, you have the n number of servers, and you don't want to have a specific IP for each and every server. So what you do, you put all those servers behind a load balancer, and the request will be routed on the basis of the round robin or the availability of the target. So that was the main reason for creating the load balancer, just to distribute the load. Apart from that, nothing.
Okay.
Okay. Now guys, you can see that I have mentioned one term here, that is it does not supports the WebSocket. Now what is WebSocket is here? So WebSocket is very important term. Okay. Those who don't know about WebSocket, so it is very important communication protocol. Okay. Which will provide bi-directional or full duplex. Full duplex means bi-directional communication between your server and user, or you can say client. Okay. So because this feature was not available, it was having some lag while doing the full duplex, so the communication was not proper. That is why uh, we uh, we told that it does not support the WebSocket, so we have obsoleted such kind of a load balancer. But because it's a part of AWS, questions can be asked that what is the difference between application load balancer, classic load balancer, network load balancer, and gateway load balancer. So that is why I'm using it here. So how you can create it? Simply click on create, just give the name, let's say test CLB. Okay. Internet facing VPC we have given. I am selecting the IP addresses here. Security group is already there. HTTP is there. Health check. Okay, you can see it is using this index.html, but I'll use simple slash. Now you can see it is asking for the instances to be added here directly. It is not looking for any kind of a target group. Okay, it is not looking for any kind of a routing based mechanism, nothing it is looking. It is actually going to entertain the same kind of applications. Let's say if you want to handle the content based or path based routing, we can't do with this. So here all the things, when we click on create load balancer, we are able to create load balancer. But into the network load balancer and the application load balancer, we need to create the target first, then only we can create the load balancer. But this load balancer is not supporting any kind of those mechanisms. That is why it was obsoleted. So you can see classic, the status is unknown, it is getting provisioned. Yeah guys, so these are the three type of important, not I would say most of the important are network and application load balancer, but you should know about the classic load balancer also. If you have any doubt till this point, please let me know.
No.
So in real-time production environment, do you still use a classic load balancer?
Sorry, your voice is a bit choppy.
No, real-time production environment, do you still create the classic load balancers?
As of now, people are obsoleting it, because if their infra is created already on there, they are in a process of migrating it. But from last 5 years, I have seen nobody is using the classic load balancer anymore.
Okay.
AWS also has recommended not to use classic
Correct.
load balancers.
If anything goes wrong with this kind of a load balancer, they are not going to provide you any support. Okay, now the next type of a load balancer is the gateway load balancer. What is the use case of this gateway load balancer? Guys, right now whatever the load balancer we have created, the infrastructure is in AWS only. Okay, but consider a scenario that there are, you require to have an integration with some third party application which is not the part of your organization, but still, because it's important for your organization to have a communication with that third party URL, you have to use this gateway type of a load balancer. Okay, gateway load balancer. So the very first thing is, it is designed to work on third layer of OSI model, that is called the network layer. Okay, and it is specifically used to deploy, scale, and manage third party virtual applications. So when I say third party virtual applications, it would be like firewall of some other user, security intrusion system. Okay, it can be any kind of a packet inspection system. Okay, so those you need to use. Okay, now what are the use cases of using the gateway load balancer? So if you want to integrate, majorly this is being used into the security compliance organization, where if we want to integrate the security applications. So when I say security applications like firewall, or just think about any kind of a security application, you can integrate this with the gateway load balancer. Always remember, in this kind of a load balancer, the target type is always application, you can say appliance VM. You cannot have any other target group here. Okay. Also, if I would say, this is okay. Yeah, it basically handles the health checks like HTTP and HTTPS and TCP. This is all. Now let me just show you. It will give you a better picture. When I click on create load balancer, it is asking that what type of a load balancer it is. So let's say I'll give test gateway load balancer. You can see that I have selected all the details here. IPv4 dual stack. It is asking for the listener router, IP listener routing. Means, first of all, you can see that it is not looking for any internet gateway, or sorry, internet load balancer or internal load balancer. Why? Because we all know that it's a third party. It is going to support the third party things, so it will be the uh, it is going to use the IP only. So we can simply create the target group for such kind of a load balancer. Okay. So when I click create target group, the target only will be the uh, instances. Okay. Select the instances, give the target group name, let's say test ALB. This is the only protocol that we should use for the gateway load balancer. Okay. This will be the port for this. Health check we have selected. Next, it is going to ask, okay, because here my this specific instance, it will not be the application instance, it will be the say instance where my security things are running, and I need to integrate it with some third party application. I cannot expose my each and every application with this. So that is why majorly this kind of whatever the instances you have which are having your security related components, you are going to use it there. Okay. Include as pending. And guys, always remember, this is the costliest load balancer that you will have in AWS. So register targets. So once you click on register targets, you can see this is registered. I'll simply this one. This is done. Okay. New tag summary is there. So it is getting created. You can see it is having listener. Okay. If I'll go to the load balancer simply, and if I'll click the GLB, it is still provisioning. You can see that this load balancer is not giving us any IP address. Why? Because we are not going to communicate here. We have simply taken an IP address, and now that IP address is going to communicate with the third party URLs. You can see we don't have any DNS here. So whatever the IP address we have used here, okay, so those are going to you can see this is if you want to have any kind of an integration, so we simply create an endpoint and give that endpoint to the third party. They will whitelist it at their end, and then the third party will start working with this kind of a load balancer. So guys, if you have any doubt in the load balancers things, please let me know.
So can this third-party tools be any resources from other cloud providers as well?
Sorry, can you please repeat?
No, can this third-party tools be resources from other, cloud provider?
Yes, it can. It can use the other cloud providers load balancer resources also. You need to create the tunneling between them. Then that is a complete approach that when we are going to talk about the VPC. But yes, we can do that. Okay. So guys,
Because
yeah,
uh, every time while creating a load balancer, it creates a VPC ID on this VPC.
VPC is your virtual private network, or you can say it will be a network that is associated with your account, and whatever the resources you are going to create, those are going to use that specific network. We can create our own network also, that is called the private network, because right now we are using the default account, so we have not created any custom VPC. That is why we are using the default VPC. So but we can create our default VPC and we can use it.
Okay.
It's a complete network where you have the IP address, router, switches, transcoders, everything will be there.
Okay.
So how do this gateway load balancer communicate with other third party things? So through IP only. So the IP is from where like we have to uh, enable
So
like
here you can see we have the integration. Then what we need to do, go to the integration, create an endpoint for this. Okay, give the endpoint, let's say, for the private connectivity, we need to give this endpoint, and whatever the endpoint URL we will have, we need to provide it to the third party vendor. Or on the other hand, what you can do, whitelist the, you can see when I go to the this load balancer, there we have given a server. Okay, into the security group, whitelist everything related to your third party requirements and create a gateway load balancer. Then what will happen, because we have our own instance behind the load balancer, and we have whitelisted it for the
I
third
couldn't
party
get you
vendor,
first
so it will
voice.
start communicating with it.
I couldn't get your voice for like yeah whole like
Am I audible?
no sorry yeah.
Okay. So how this gateway load balancer will work? So let's say this is your third party, okay, and this is your complete infrastructure. So what this will do, you will have a gateway load balancer. Okay, this will be your gateway load balancer. Uh, Gateway load balancer. So what will happen? You will have your servers here, okay, and those servers will be behind this load balancer. So what you will do, first of all, you will create this gateway load balancer. You will create your instances behind this, okay, and also what you're going to do is you're going to do the whitelisting between these two. When I say that, whatever the integration protocols or whatever the IP addresses will be required, you are going to whitelist it between here. Okay, whatever the request will come to your gateway load balancer is actually going to communicate with your this third party, with your instance, and your whatever the security compliances you need to follow, those are going to be entertained with this kind of a load balancer. So actually it is, or in a very simple language, you can say that you are using the gateway load balancer so that you can communicate with any third party infra in your AWS.
The communication will be done only with the endpoint kind of thing like
Correct, correct.
we- okay now I got it.
The chances of using gateway load balancer will be 10 to 20%. Most of the time you are going to entertain the network and the application load balancer.
Yes like we are using like VPN tunnels to get the infra so
Correct,
it's not
correct.
necessary.
Because it is also very costly load balancer. So people, AWS is just creating, because they are giving you the managed service. Apart from this, most of the people are creating the load balancers and creating the tunnel and getting connected with them.
Yeah now I got it. Thanks.
Okay guys, any other issues you have? Okay, if you don't have any issues, can I delete this classic load balancer? Even I just, you can check this by hitting the classic load balancer. Page is getting rendered. But here, when you check the classic load balancer, you are not getting any state, you are not getting any IP address. Why? Because after some time, even you won't get this kind of a load balancer on their dashboard also. This will be completed or completely obsoleted from their infra. So let me just delete this load balancer. Now the next thing we have is the auto scaling group. What is this auto scaling group? What is the use case of creating an auto scaling group? How we can use this auto scaling group is completely a matter of that how your applications is designed and what is the use case of this. So we will discuss this auto scaling in a very detailed manner. But before that, it's 11:33. Let's take a very short break, and we will rejoin at 11:45, and we will start the auto scaling part. Okay. Yeah, Mahesh, you were raising your hand. You have any questions? Hello, Mahesh, do you have any questions? Okay, I hope the question is not here. Okay, so let's rejoin at 11:45, and then we'll start the rest of the things. Yeah, hi guys. I hope all are back now. Hello, am I audible?
Yes, yes,
Yes,
Vikas.
Okay.
yes, because
So I'm just sharing my screen. Okay. So we are going to talk about the autoscalers. Now, what are those autoscalers? What is actually autoscaling is all about? So we will talk each and everything in a very detailed manner. So first of all, guys, uh, how we are going to or why we are using the auto scaling. Okay, so first, auto scaling. Okay, so consider a scenario. Let's say you have created a server of 10 g, let's say 4 GB of space, and or let's say 8 GB of space and 4 core of CPU, and you found that your application is running fine, but there is a sudden spike in your application. Now, because of that sudden spike, your application was down for some time. Okay, so next day what you did, you have created 4 to 5 different servers of the same specification to manage the load. Now what happened here is the spike didn't occur or didn't reoccurred for the spike has not reoccurred for almost 3 months or 4 months. Now in that scenario, what happened, because you have created 4 to 5 new servers of the same spec, and you have not faced any kind of a spike for a for next 3 months, so you have paid the amount for that as well, which is not a good solution. So what you basically, uh, auto scaling is of two types, I would say. Okay, now first of before talking about or before uh, going more deep dive related to auto scaling, let's take a scenario that in that I was telling you that for the 3 months you have paid the n number of amount for the servers that are exactly not in being used because you have not faced any kind of a spike. Now, what do we have any alternative for it? Yes, we have the alternative that is called the auto scaling. Now, what auto scaling will do? It will, let's say, you create some conditions, you create the auto scaling groups, you create some conditions, and when the condition got matches, let's say if the server find any spike around 70%, of the server find any kind of a spike of 80%, or CPU consumption is n percent, or the memory consumption is n percent, or the request is being, let's say, n number of requests are there. So on the basis of that, you create certain rules that okay, once if any of the condition got matches, my new servers should be spinned up within within a few minutes. Okay, so that is the role of auto scaling. And once your condition is normal, the same servers will be terminated. So that is the role of the auto scalers. Now, what will happen in this scenario? You have created the high available infra, you have not beared the cost for the very long time, because 1 or 2 hours is enough to make any application in a very healthy state. Okay, you have because your main focus was on cost optimization. Yeah, you have achieved that, you have achieved the high availability, you have achieved the fault tolerance. So all the three parameters you have achieved with the help of the auto scaling. Okay, now guys, auto scaling is always of two type. The very first one is the vertical auto scaling. Okay, and the second one is the horizontal auto scaling. Now, what is vertical auto scaling and what is horizontal auto scaling? Let me give you an example for that. Is, let's say this is your server. Okay, and the server is of, let's say, T2 dot medium, that will have around, I think, if I'm not wrong, it will have around 2 core of CPU and uh, 4 GB of RAM, etc. Okay, now this is your server. now you have got a sudden spike on your server, and what you are doing right now is you are creating new server with some more configuration. So when I say more configuration, let's say now you have created uh, T2 dot large, which will have around 8 GB of RAM and 4 core of CPU, something like this. Okay, so and again you faced an issue and you created another server of high specification. Okay, now guys, whenever your scaling is in terms of the changing the configuration or changing the specification of the server, okay, whenever your uh, so you can see from 2 GB or 2 core to 4 GB, then 8 GB, then 16 GB, you are going like that. So such kind of auto scaling is called the vertical auto scaling, where you are keep on increasing the specs of the server. Okay, specs of the server, let's say etc, 2 GB to 4 GB to 8 GB to 16 GB, etc. Okay, so such kind of auto scaling is considered as the vertical auto scaling. There is another type of auto scaling which is called the horizontal auto scaling. Now what does that mean is, let me just give you an idea of that. So let's say you have a server. Okay, let's consider a scenario. You have a server. Okay, and you got sudden and this the server is of, let's say, 2 GB of RAM and uh, sorry, 2 core of CPU and 2 GB of RAM. This is the specification of the server. Now what happened, you got a sudden spike on the server. Now all those servers will be behind a target group and all those things. I'll come to that part later on. So what you do on the basis of the spike, you are spinning up the same infrastructure parallelly. Means you have spinned up around 4 new servers of the same specification. Okay, let's say now you have created, all of the servers will have the same specification, 2 core and 2 GB of RAM. So this kind of, whenever the auto scaling goes like this kind of auto scaling is called the horizontal auto scaling, where you are not increasing the specs of the server. Okay, but you are launching the n number of servers of same specification. So that is the main difference between the horizontal auto scaling and virtual auto scaling. Now if you have any kind of a question till this point, please let me know. Guys, why I am asking you this, because when, although it seems very small definition here, but when we talk about Kubernetes completely works onto the concept of the horizontal pod auto scaling. So and this is, I think, uh, because we are talking about the auto scaling, so I thought that I should tell you this major difference between the horizontal auto scaling and the vertical auto scaling. I'm again asking, if any one of you is having any doubt till this point, please let me know.
Vikas, one doubt regarding
Yeah, please tell me.
the vertical auto scaling. Like you said, like in terms of specifications, you'll be increasing the specifications, right? So will
Mhm.
it be on the on the same
It will be
server,
on the
or
same on the
one
same
will be
server.
adding a new new storage or whatever it is in addition to the first one?
No, the this vertical auto scaling will be on the same resource.
Okay, same resource. Okay.
Or let's say if you are creating a new resource, it will have the uh,
Highest.
high specification as compared to the previous one.
Okay.
So while configuring it, we have to give like whether which auto scaling part we are going to go kind of thing, or
No.
it will take. I'm a bit confused on the how we do like how it would scale if the hit is high in the server. Like
Are you talking
we have
about?
to mention it like in the vertical scaling or auto scaling kind of thing, or it will take automatically.
So horizontal auto scaling will be performed automatically. Okay, but for vertical auto scaling, we need to do it manual process. How to do this? Let me just show you. Let's say if I'll go to the instance. Okay, and guys, one more thing: horizontal auto scaling does not require any kind of a restart of the resources. Okay, whereas vertical auto scaling requires the restart of the resources. Example: this is your server which is having the instance type of t2.micro. Now I, because I have monitored it for few months and I found that this is not up to the mark and we required a higher specification. So for that, what we need to do here is simply select the respective resource, click on the instance state, click on stop instance. First of all, stop this instance. Let's wait for this instance to be stopped. Yeah, the instance is stopped now. Now I need to perform the vertical auto scaling on this. So what I need to do here is click on instance actions. Okay, there we have the instance settings. There we have change instance type. Okay, I need to just use another instance. Let's say if I, instead of this, I wanted to use t2.medium. So you can see that my earlier instance was having one core. Now this will have two core. Earlier instance was having 1 GB of space. This will have 2 GB of space. So simply I can click on change instance. Guys, remember, instance type can be increased as well as it can be decreased. But if I talk about the volume, volume can only be increased. You cannot decrease the volume. Let's wait for this to be yeah, so t2.medium is done. Start the instance. So yes, now you can see that this instance is restarted. If I go on to the server, okay, ssh -i test gobi.ubuntu at the rate, not ubuntu, I would say ec2 user at the rate. So now you can see this server has been scaled. This server has been vertically scaled. You can see that 4 GB of RAM and 2 core of CPUs are there, CPU 0, CPU 1. So now we can see that yes, we have implemented the vertical scaling on this server. I hope I'm able to answer your query for this vertical scaling.
Yes, Vikas.
Okay, so because it is going to cost me, so I'm going to reduce the specification. How to reduce it? Simply stop this. Without stopping the server, you cannot change
So
its specification.
because auto scaling is something the changing the type of the instance. That's it, right?
Yeah, sorry, it will be the scaling, not vertical will be the scaling, but horizontal can be the auto scaling.
Okay. And what is it like if the utilization goes high and
Mhm.
we require more resources? So in that case,
We
the
are
resources should be added automatically. That is not auto scaling, right?
No, no. The thing that I have shown you is the vertical scaling, where you are changing the resource type. But when there is a spike in your infrastructure and suddenly some of the suddenly new servers are provisioned with the same specification, those are called the horizontal auto scaling. That I'll come to that part. Okay.
Okay.
Because right now I just wanted to show you how you can scale up and scale down the servers, because this is also one of the activities that we need to perform for the cost optimization. So I'll go to the change instance type. Let's wait for this to be completely stopped. Yeah, so it is stopped. I'll come here and instance settings, change instance type. I'll again go to t2.micro one, the free one that I was using it. Okay, and simply change instance type. And once the instance type is changed, start the instance. So yeah, this is vertically uh, scaled. Now let's jump on to the auto scaling part. Okay, so auto scaling, what we need to do, how we can perform this auto scaling, what will be the scaling policies we need to implement, etc., etc. So let's directly jump onto auto scaling group. Click on create auto scaling. These are the 7 steps that we need to perform while doing the auto scaling. First of all, we need to choose a launch template. Now what is this launch template is all about? So guys, in this launch template we need to select that which AMI we should use, what should be the instance type we should use, what should be the security group we should use. Remember, here we need to keep all the things similar to the server that for which we are implementing the auto scaling. Okay, so I'll give test auto scaling. Now launch template. Now launch template, basically we need to create a launch template. What does that mean? Basically, launch template, we, as I told you, that we need to select the AMI instance type. Okay, so let's say test launch template. There is nothing required here. Template source. Now it is asking for the AMI. Okay, which AMI you are going to use in the organization? Basically we use the uh, organizational AMIs, but yes, here we use the browse more. So we have this AWS AMI. I'll select this. Okay, I have select this, or you can say, if I'll click on currently in use one, so I'll check that if there is any kind of a AMI which I'm using it right now. So yes, this is the AMI we have. Okay, then it will ask that what kind of a instance we want to use. So let's say if I wanted to use t2.micro, is there any key pair I wanted to use for all the servers? Yes, I wanted to use Now networking, remember, it should be the same as your running instance. Okay, so for that what I'll do is I'll simply go to EC2 dashboard. There we have, if I click on the networking part, we have this VPC ID. Okay, so and the subnet of the instance will be this one. So I'll copy this subnet. Yeah, this is the subnet. Okay, availability zone, it is going to use the same select an existing security group. Yes, just check the security group that you are using. Go to the monitoring part, sorry, security part. There we have this security group. So I'll copy this. I'll use this security group here. Okay, this is the security group I'm going to use. Is there any kind of a, okay, okay, yeah. So don't include. Okay, we have selected most of the things here, and auto assign anything I wanted to perform. No, storages, volume, this will be used. Okay, and create the launch template. So we have created this launch template. Okay, this one. So default version, all these things we can, whenever we are going to change anything into it, it will have the respective version here. So now let's load it. Test launch template, select the version, whichever the version you wanted to use. Next is this. So it is asking for the VPC. Okay, it is asking for the availability zone. So once we click on the balanced best effort, so on the basis of the you can say on the basis of the availability zone or high availability, it will launch the instance. Okay, next. So okay, I'll select that where I need to launch. I'll select all the three in one availability zone. Okay, is it? Yeah. So A and B I have selected. Next. Now it is asking that whatever the servers we are going to have, do we need to attach those servers automatically to a existing load balancer or attach to a newly created load balancer? So, and if you don't want to attach to a load balancer, these are the three options. So guys, if you click on this here, you need to create the load balancer, but if you select the existing one, okay, it will ask that which load balancer you wanted to use. So I'll use the uh, test this load balancer. Okay, this is the target group of an existing load balancer. Basically we have these four target group. Let me just delete all the respective target group so that you can have the better picture. I'll network load balancer recharge, this one. I'm going to delete all those three. Delete and delete. So I have deleted the three target groups. Oh, okay. Delete listener, confirm. Okay, then delete load balancer, confirm. I'll go to the target group now, and let me just delete this target group. Delete. I'll try to delete this one also. Okay, so we have done our part here. Okay, so I'll simply refresh it. It is giving us two load balancers. Okay, So I'll use this one. Then it is asking that do we need to, for the networking capabilities, do we need to attach? So by default, let it be no VPC. Enable zonal shift. Let's say if one of the instances is unhealthy, then it will be shifted to another one. This specific feature is basically being used for the high availability. Okay. uh, if you need to perform the health checks, elastic load balancing health check, on the basis of the elastic load balancing health check, let's say if any of the server health check got failed, then a new instance will be created. Grace period is 300 seconds, means almost 5 minutes. Next, now it is asking for the configure group, how many instances you want to create. Okay, let's say desired capacity, let's say if I'll give 3, then what is the minimum and what is the maximum. So at least one server will be live, and depending on the conditions that we are going to put ahead, it is going to launch the maximum 3 instances. Okay, now do we need to have any kind of a scaling policies? So when we say no scaling policy, so what it will do, our auto scaling will group will remain as its initial size, that is one, and not dynamically resize. But when we have to mention the target tracking policy, target tracking policy basically that how we are going to create the resources. So when I say the target, this average CPU utilization, okay, whenever my CPU utilization goes, let's say 50% or whatever, for the 5 minutes, okay, it will scale up the things. Whenever my network goes some value, it will go, or the same thing, whenever the request count goes specific, so it will work accordingly. So let's say if I'll give average CPU utilization, I'll give the target value as 5. Okay, and instead of this one, I'll give only 30 minutes. Now instance maintenance policy, that how the instances are going to be maintained. If I say make no policy, means it is going to simply launch the instance, it is not going to make any kind of a changes. Flexible means on the basis of the uh, results, it is going to either delete the instance first or launch the instance first. Terminate or launch means, first of all, it will terminate the affected instance and then launch a new one. Basically in the organization, we basically use the no policy. Okay, additional capacity, do we need to mention? Nothing. Additional settings, do we need to mention? Nothing. We don't want to mention anything. Click on next. Any notifications you wanted to add, notifications related to launch, terminate, fail to launch, anything you want to have. Basically, once you select this notification, you will have a alert on your respective email addresses. Okay, click on next. Next, this is done. You can see the load balancer is there, auto scaling, launch template, this disabled. Okay, EC2 and ELB health check, desired capacity is 3, and click on create auto scaling group. So you can see that our instances right now are 0. Okay, let's wait for this to be, it is basically, it will take few minutes to be to provision the resources. It is still in a updating capacity. So you can see that number of instances right now are 3. Why it is 3? Because we have mentioned that whenever the, if I'll go to the dashboard, okay, if I'll click on instances running, so you can see the instances are auto scaled. Why those are auto scaled? Because we have mentioned that whenever the CPU utilization goes above 5, okay, if you check the monitoring, whenever the CPU utilization goes above 5, it will launch the instances. So if you check here, the CPU utilization is some specific percentage, okay, so it has launched the respective instances. So in this way, it and also you can see all the resources are running. If you go to the load balancers, okay, if you go to the load balancer, you will find that all of the instances are automatically attached to the respective servers. You can see there are two rules here. We have, this is our rule number 1. So I think we have deleted this part. Target groups. This is our target group. Okay. Under the targets, you can see all the resources are there. Although those are in healthy state, because it will, because remember we have given slash there, and these are our newly created instances without any configuration. That is why it is getting failed. But if we take a AMI of the existing one and we use that AMI to launch the instance, the issue will be resolved. So guys, in this way we basically create the target group and auto scaling. Now if you have any doubt, please let me know.
Because I have a doubt.
Yeah.
So while creating the auto scaling group,
Mm-hmm.
where we have mentioned that instance ID, this instance, it has
No,
to
no.
check.
In the target group, we don't define the instance ID. We only define the AMI ID.
Okay.
So once you
So
click,
whatever the instance which is running with that AMI, it will be auto scaled.
correct. So you can see when I created this launch template is nothing but it is going to create a template that how your newly created instances would look like. So here we need not to select the instance ID, we need to select the AMI ID, because we are using the default parameters here. That is why I have selected AWS ID. But in our organization, we need to use the currently in use or browse the AMI ID. We need to select our AMI ID, that is the my AMI, select the AMI, and then respective servers will be launched.
Okay.
So in this way this will happen. And remember guys, into your target group or into your load balancer, all these servers will be in the pattern, those will be live till the condition matches. Means if the CPU utilization is around 5, it will have the those servers will be live. But let's say if I'll change the auto scaling group, okay, let's say if I'll click on this and edit, and here you can see 1 3 launch template is there, instance type is there, we have everything we have mentioned. Okay, advanced configuration, number of instance, default termination. This is policy number 1. We can create another policy here. let's say terminate health check and all those. I think we need to not update. I need to delete that policy. Then only it is going to work. Yeah. So I need to create a new launch template, and then it will work accordingly. So instance management, okay, integrations. I don't have any kind of integrations. If I click automatic scaling, so you can see that we have given. Yeah. One more thing that I wanted to tell you here is that automatic scaling is, you can see we are getting options like, if you scroll it or if you expand it, dynamic scaling policies, we are having predictive scaling policies, scheduled action. So what is this? So let me just tell you. Meanwhile, if any one of you is having any questions till this point, please let me know.
One more, because does AWS supports only horizontal scaling, auto
Sorry.
scale?
Yeah, this will only support the horizontal auto scaling.
Okay, so if we want to increase the server space or storage, we need to do it manually.
Correct.
Okay.
Okay, now here you can see that under this policy we are having dynamic scaling policy, and the another one is the predictive scaling policy. So what is the major difference between these two is, so guys, dynamic space yeah, scaling policies. So the very first one is the dynamic scaling policies. Okay, dynamic scaling policies are required when you want to have the real time adjustment based on your metrics, whatever the metrics you have defined. Okay, so this is very important for you when you want to respond immediately. Okay, and it uses your CloudWatch or uh, metrics like CPU, network, or any custom metrics to monitor the things. Okay, uh, for this, when I talk about the dynamic scaling policy, okay, let's say if I'll click on this, the create dynamic scaling policy. Under this dynamic scaling policy, you can see that we have three type of policies: target tracking scaling, step scaling, simple scaling. What is the difference between each and every? Let me tell you why I am keep focusing on this, guys, because once you are talking about the Kubernetes part, all of these things are going to be there. So I'll try to clear your uh, doubts here only. Okay, so the very first one is the target tracking policies. So this target tracking policy, this is the recommended one. Okay, so basically it checks for the specific thing. For an example, you can see that in our policies we have mentioned that whenever the CPU average goes above 50, so it will start working onto it. So this is called the target tracking policy, where we set up a threshold. Okay, we set up a threshold, and accordingly the ASG, that is auto scaling group, will work. This is called the target tracking scaling. Second one is the step scaling. Okay, when you click on the step scaling, you can see that, so what this step scaling will do, so it will add or remove instances based on how much metric exceeds the threshold. Means, so once I select this, you can see I'll give policies. So whenever, let's say if any capacity unit let's say 1 matches. Okay, so it will add okay, so we need to create an alarm here. On the basis of that alarm, let's say if we got an alarm, okay, the CPU utilization is high or a memory utilization is high, it will add that amount of capacity. It is not going to add more than that. So that is called the step scaling, means by 1, by 2, by 3, something like this. For an example, in this one, what will happen, let's say if the alarm is keep coming for the 5 minutes, so in every 5 minutes it keeps on adding one resource. So that is called the step scaling. But in the production scenario, step scaling is not recommended, guys, because let's say if your load is too crucial or too much heavy and you have opted for the step scaling, let's say it will be added for 1 in 5 minutes, for 2 in 2 minutes. Consider a scenario where you need to have 10 servers immediately to be spinned up. So with this approach, it will take around 50 minutes, and 50 minutes of downtime can cause a lot of business loss. So that is why it is not recommended to use step scaling. The third one is the simple scaling. So what the simple scaling will do, so it will trigger one scale action. So it will only going to trigger for the one time, not every time. Like the step scaling, it will only trigger for one time, and that's it. After that, its job is completed. So that is why it is also not recommended to use in the production. Guys, any questions you have?
Because can you explain in brief once again?
Okay, so let's say if I talk about this, first of all, if I talk about target tracking scaling. Okay, so what this target tracking scaling will do, let's say you have this one server, and suddenly what happened, there is a 5 core of this is of 2 core of CPU and 4 GB of RAM server. Now what happened, you have given a condition, hey, whenever the 60% of the CPU or whatever the condition you are creating here, let's say whenever the 60% of the CPU or average network or average network out or application request count, let's say load balancer request count, or any any of those condition matches. Okay, so it will if any of the condition matches, so it will spin up the same resources depending on the minimum and the maximum replicas that you have defined. So this is called the target tracking scaling. Means it will first check that whether the respective target is getting matched, or whether the condition is getting matched on the auto scaling or not. If yes, then it will spin up the infra. If not, then it will not. Next one is the step scaling. What step scaling will do here is, let's say you have this 2 core and 4 GB of RAM. Okay, and you have given a condition that, okay, according to here, the CloudWatch alarm will work. CloudWatch alarm, according to your cloud, you have to integrate it with the CloudWatch. Okay, CloudWatch is nothing but it is a monitoring service. Okay, so what it will do, it will monitor on the basis of this CloudWatch. CloudWatch will trigger alert, hey, you are having this kind of a RAM and CPU for your system. Okay, and it will check for the next 5 minutes. It is going to check for next 5 minutes, and if the condition does not resolved, it will spin up one instance. Again, it is going to check for next 5 minutes. If the condition does not resolve, next it is going to create another instance. Then after 15 minutes another, then after 20 minutes another. So you can see in the 20 minutes you have launched 4 different instances. But the drawback here is, let's take an example that your server is has received a lot of load, and you cannot go with this approach. Suddenly you want to provision multiple instances. So in that scenario, guys, we are not going to use the step scaling. Okay, the third one is the simple scaling. Let's say this is your system, your cloud monitor gives you an alert. So in the fifth minute, it is going to launch one unit, and that's it. After that, it is not going to launch anything. So this is called the simple scaling. I hope I'm able to answer your query now.
Yes, Vikas.
Okay. Then the other scaling we have here is just I'll go to the automatic scaling. The predictive scaling policies. Okay. Now what is this predictive scaling policies is all about? So guys, this kind of a scaling policy is very much you can say advanced. So what it generally do, let's say you have this server. Okay. So what this will do, it will for so this policy predictive forecast policy. So what this will do, predictive forecast or predictive, yeah, predictive scaling, not forecast. So this will forecast future load using the machine learning and scales ahead of time. Example, let's say you have a load on your server and the load keeps on increasing. So what this will do, okay, scale, when we click on scale based on the forecast, so what it will do, it will check that okay, there will be a very higher chances that the CPU utilization can goes above 50% per instance. So it will, what it will do, it will create the servers for you in advance. Means it is not going to create the servers at the time of the trigger of the uh, alert, but it is going to create before that. So this is the role of the predictive scaling. Predictive scaling, again, it is not recommended because there are sometimes we have the false alert also. So that is why it is always recommended to use the dynamic scaling policies. Now guys, if you have any kind of a yeah, one more thing I wanted to add here, what are the parameters that we should choose, either predictive one or the dynamic one? So guys, remember, whenever you have a scheduled traffic example, so we are going to have the festive seasons in some time in India, let's say the Janmashtami season and Independence Day season. So we are going to have the sale on various e-commerce platform like Myntra, Amazon, Flipkart. So they are pretty much sure that they are going to have a heavy traffic at that time. So in that scenario, they can opt for the predictive scaling, where on the basis of the request count, the it can predict the forecast that okay, load can be there, so it will launch the instances in advance. So this is the example of using the predictive scaling. Now if you have any kind of a doubt guys, please let me know. Yeah, Nanda, please tell me your issue. Hello guys, any issues you have?
No, Vikas.
Okay, now let's, this was all about the auto scaling, that how we can use that auto scaling. So what I'll do, I'll simply delete my auto scaling. Another thing I wanted to tell you was yeah, this is all that we have. So let me just delete this auto scaler. I'll delete this launch template also. You can see that I have given a condition that it should launch a single instance only because I have terminated my instance. Okay, so it keeps on increasing it keeps on increasing the respective servers. So what I'll do, I'll delete all of them in one go. Let me go back. I'll check that whether I have any where it's keep on deleting. So guys, in this is all that we can have related to the EC2. Related to volumes and snapshot, we have a dedicated session for it. So I'll come to that part. After that, we have the VPC. So I'll come to VPC part once. Let's wait for this to be deleted once. I'll delete the load balancers also. Guys, I would recommend you to that whenever you have done with your testing part, always delete your resources. Otherwise, it is going to cost you. So target groups are cleaned. Load balancer is also cleaned. Let's go to auto scaling group. It is getting cleaned. I'll check the launch template. It should also be deleted. So this is deleted. The auto scaling is going to be deleted. You can see it is silently deleting all the instances. All the instances are terminated. Auto scaling. Yeah, auto scaling is also deleted. Yeah. So guys, the next thing we have here is, which is, you can say, the backbone of AWS, which is called the VPC. Without VPC, you cannot imagine to create any infra on AWS. Okay, so first of all, what is VPC and why it is so much important for us to have in our infrastructure? Okay, so first of all, to search for VPC, guys, we need to click on VPC. Okay, yeah, so this is the complete dashboard of VPC. So what VPC is all about and what it is going to do for us in infra. So VPC, it is an acronym for virtual private cloud. Okay, it is a logically isolated network environment in AWS, okay, in which we can launch and manage AWS resources like EC2, RDS, load balancers, okay, and etc. Now, the thing that we should understand, that why do we create VPC? So guys, right now what we are doing, whenever you create any AWS account, okay, this will have, it will provide you a default VPC for your all regions. So once you click on North Virginia region, you can click, when you click on North Virginia region or any region in AWS, every region have their default VPC. Okay, but we are working in Mumbai. Let's go back to Mumbai. So now, although we are using the default VPC, we are creating our resources. But what is the drawback of using default VPC? That we don't have the control over the networking here. Okay, in default VPC, we don't have any control over networking. So when I say over networking, we are not we have not defined our own IP ranges. We have not created the subnets as per our organizational needs. We have not created the route tables. We have not created the internet gateways. So what are these? I'll tell you the definition, but in a very simple language, if I would say, what is the use case of creating a default VPC? That we can launch our resources, but what is the drawback? The drawback is we don't have the control on the networking environments. Okay, so this is about the VPC. Now we do have some default, or we have some core components of VPC. Okay, so if I show it you with a design, let's consider VPC is a box here. Okay, this is, now I'll show you the complete AWS diagram. Go.io. Guys, with the website that I have open in front of you, these websites you also gonna use in your infrastructure, because as being a DevOps engineer, you were responsible for creating the architectural diagram. Okay, so let's take an example that this is your infrastructure. This is your complete infrastructure. Okay, and these are some of the symbols. Okay, so there we have VPC. Okay, so this is our VPC, a default one, and under that VPC we have some core components. Now what are those core components is all about? core components of VPC. So the very first one is subnet. Okay. The another one is the route table. The next one is the internet gateway, that is also called as the IG. Okay. Then we have net gateway or net instance. Then we have elastic IP. We have security groups. We have NACLs. NACLs, that is an acronym for network address, uh, yeah, network access control list. Okay. We have DHCP option set there. DHCP options set. We have VPC peering there. VPC endpoints there. And last one is transit gateways. So all these all are the core components of your VPC. Guys, always remember, you cannot crack any DevOps interview without knowing VPC. Why? Because being a DevOps is not only to create or spin up their infra, but being a DevOps, you should also responsible for architecturing their infra. So when I say architecturing the infra, you should understand the networking topologies that is being provided by AWS or by any cloud provider. Because right now we are talking about AWS, so that is why I have mentioned the VPCs here. So let's go with those core components one by one. But before that, if you have any doubt till this point, please let me know. Okay, if no questions, then let's start. I hope you are comfortable with the definition of VPC. All of you guys. Guys, please say yes or no.
Yes,
Okay. Now,
Yes.
the very first thing here we have is subnets. What is this subnet, and why do we require subnet, and what is the use case of creating a subnet? So basically, it is a sub network of the VPC, or you can say subsections of a VPC. Okay, let's say you have your this infra, this is your complete infra. We will create one subnet here, this is another subnet, this is another subnet, and this is another subnet. Now inside those subnets you have to create your resources. Okay, example, if I'll come to the EC2 part. So here you can see that when I click onto the instance, when I click on the instance here, you can see this instance is having a, under the monitoring, it is having a subnet ID. What does that mean? That under this complete VPC, we have cut down it into some subsections, and each subsection is having their own dedicated IP CIDR. Okay, or dedicated IP ranges. So that is the role of subnets in VPC, where you can say It is a subnet of the VPC, or you can say subsections of VPC. Here we can create a public or a private subnet. Now this question is mostly being asked, hey, can you please tell me the difference between public and private subnet? So first of all, we talk about public subnet. So this is the subnet which is having route to the internet directly. Means whatever the directly through internet gateway. Okay, means whenever you launch any resources into this subnet, okay, those resources or anyone outside of your VPC can communicate with those resources or directly communicate with the internet. Okay, now the another one is the private subnet. What is the private subnet? Means this will not have direct internet access. Okay, you required some additional components to connect with internet. Now according to you, now I have told you the definition. According to you, which subnet we should use, the private subnet or public subnet?
Private.
So yes, we but here is a hack, guys. We need to use both the subnets. Why? Because whenever about the private subnet, we should launch our database servers. Okay, we should launch our backend server or application services into the private subnet. But when we talk about the public subnet, in the public subnet we can launch our load balancers. Okay, we can launch our jump host or any instance which is public facing. So these three kind of these three kind of resources, we can say that yes, we can launch into the public subnet. Okay, now this is the public subnet. The next component here is which is called the route table. So this will define that how the traffic is directed inside the VPC, or simply you can say that route table is responsible to manage the traffic inside your VPC, that which request should land onto which resource. Okay, this is route table. The third one is the internet gateway. What is this internet gateway is all about, guys? So this will allow internet connectivity, okay, between your VPC and the public internet. If you have not attached any internet gateway with your VPC, you cannot connect with any external service, or any external service cannot connect with your VPC. And always remember, this will be required for public subnet. We don't require internet gateway in private subnet, we only required it into the public subnet. Then we have the net gateway or net instance. What does that mean? So guys, net gateway or net instance, so this component will allow private subnet resources to access the internet, okay, without being exposed directly. Or in a very simple language, you can say that if you have any resources which are internally being used with your or within your organization, but you want to be communicated with the external world, you have to in place the net instance or net gateway in your private subnet. And always remember, net instance or net gateway is always for the private subnet. Elastic IP, as we told you, if you required, we have already discussed about it. If we required static public IP, okay, if you require static public IP, then we should use elastic IP. Security group, we all know that it's a virtual firewall. Okay, then we have the NACL. Now what this NACL is, basically guys, there is a the question can be asked, hey, what is the difference between security group and NACL? So always remember, security group is always applicable for the resources or for the instance level, but when you want a firewall at the network level, you have to, network level or subnet level you can say, or subnet level, you have to use NACL. Okay, now next is the DNS option set. So this will control the resources to get a unique name. Means whatever the resources we are creating under a VPC, DHCP option set is responsible for giving the unique name to them. VPC peering is basically used when we want two different VPC to connect with each other. We have to do VPC peering between them. Or you can say that it is a term which is used to connect two different VPCs or allow the traffic between the two different VPCs within the private IPs. I'm not talking about public, because if it is public, you can communicate with it easily, but within the private IPs, you can have a communication only with VPC peering when the two VPCs are different. Okay. Now VPC endpoint is basically, it is a private connection to AWS service without using internet. Okay, this is all. Means you, if you want to have a private connection, you have one AWS service and you want to have a internet connection with it, but you don't want that specific service to be exposed publicly, you can use the VPC endpoint there. And last or yeah, last one is the transit gateway. When you want to connect your on-prem or your local infra to cloud infra, you should use transit gateway. So guys, these are these core components of VPC, which are we are going to use in coming days, and which are gonna be asked to you during the interviews or whenever you are appearing for the any kind of a interview or exam. VPC, all these components are going to be used there. Yeah, if you have any kind of a doubt till this point, please let me know.
Because can you explain this difference between the security group and NHCL once again?
Sure. So
NACL.
yeah, the difference between the security group or NACL, although we are going to talk about this in a very detailed manner, but for now you just need to understand that security group is only applicable at resource level, means at the EC2 instance or internet gateway or your RDS server. RDS is basically a database server. You are going to assign it to a specific resource only. Okay, but let's say this is your network, and instead of assigning a policy on each and every resource, you want that this policy should be applicable for all the resources underlying this network. So then you need to create a NACL rule. That's it. That is the major difference between NACL and security group.
Okay.
Okay.
So it's like we are allowing a traffic from this particular IP to this particular IP range.
No, we are allowing a traffic at a network level,
Okay.
complete network, not on the resource level.
Okay. Network in the sense the particular IP range you're saying. The
Correct.
particular subnet level.
Yes.
Okay.
Yeah, guys, any other doubts you have? Okay, if no doubts, then let's do one thing. Let's wrap up today's session here, because today we have done a lot of practical scenarios. In the next class, when we are coming, please have some idea about the VPC components that we have talked, because from next time onwards, we are going to create our custom infra, and we are going to launch that infra into the custom VPC. Okay, guys, thank you.
Thank you.